What's up guys, Ryan Tech here. Today I'm going to be covering some unit conversion in chemistry. So let's get started. Our first question says how many samples of iron are there in 235 grams of Fe? Now I'll pause the video and see if you can figure this question out. Okay, now let's figure out what we have to do. Now, when they say samples of iron, they're in fact referring to atoms of iron. So how many atoms, or rather samples of iron? So this can refer to as atoms of iron. Are in 235 grams of Fe. Now, if you're not familiar with the periodic table, or if you haven't memorized the periodic table, then if you don't know what Fe means, it just means iron. So Fe is iron. And what they're asking us to do overall, what they're asking us to do is they're saying convert the grams of iron or the grams of Fe to the atoms of Fe. Or rather iron. So let's get started with this question, or let's get started with the conversion. Okay, so let's first start off with our grams. So 235 grams of iron over 1 times. Now, whenever we convert grams to atoms, this is the order we go by. We go from grams to moles to atoms, and then if we wanted, we could also go to molecules. Now, so in fact, you could view it as going from very specific units to very general units. So grams are specific, then they go to moles, then from atoms to molecules. So you could view it as that. Okay. Now that we know that, let's continue. So 235 grams of Fe. Now we're gonna convert it to moles. So we say 1 mole of iron. Now we have to figure out the amount of grams in iron. Now for every 1 mole. So if you pull up the periodic table, you'll search for Fe, which has an atomic number of 26, and you'll see that the grams per mole is equal to 55.847. So let's just say 55.85. So for every 1 mole of iron, there's 55.85 grams of iron. Then, for every mole of iron, there are 6.022 times 10 to the 23 atoms of iron. Now you're probably wondering why is it 6.022 times 10 to the 23? Now whenever you're converting atoms and molecules or molecules, then you always have to use the 6.022 times 10 to the 23 number. This is called Avogadro's number. It's used whenever you're converting, say, grams to moles. Whenever you're converting grams to moles, you have to realize how many atoms are there per mole. Avogadro's number represents how many atoms of an element are there per mole. So that's what it means. And now, what's our answer? So I'm gonna get my calculator. I'm using a Texas Instrument TI-84 Plus. If you're not using that calculator, or your calculator doesn't have order of operations, I recommend you do every step individually. Which I'm gonna do that just in case. So 235 grams. Oh yeah, and before we actually calculate, just to be sure that we converted it to atoms, we could cancel out the units. So grams of Fe. Wait, oops. Sorry about that. So grams of Fe cancel out with grams of Fe. Moles of iron cancel out with moles of iron. And we're left with the unit atoms of iron. Okay, now let's calculate it. 235 divided by 55.85. You should get 4.207 or something along those lines. And then I'm just going to get that answer and times it by 6.022. And I'm going to add the 10 to the 23 because it's going to make things too confusing. I'm just going to add it in afterwards. Then, so I got 25.33. And then, for the 10 to the 23, I'm just going to say times 10 to the 23. And don't forget your units, atoms of Fe. I'm also gonna, while I'm at it, I'm gonna show you something extra. Sometimes teachers want the notation to be like a one-digit number. Times 10 to the power of x, for instance. Now the thing is, this is a two-digit number, so if our teacher wants us to make it a one-digit number, all we do is divide the 25.33 divided by 10, and we times the 10 to the 23 by 10. If we do that, we get 2.533 times 10 to the 24. So just in case your teacher wants it in that notation, then here's that in that notation. Now on to the next question. So let me just get ourselves a bit of room here. Okay, now this is what the next question says. It says, how many atoms of carbon are in a sample of 356 grams of glucose? Now, let me quickly write that down, just in case you didn't hear me properly or you want to just have it in written form. So, how many... Therefore, of glucose. Now, for those of you who aren't familiar with the empirical formula of glucose, you should have memorized it, but in case you haven't, it's C6H12O6. So you can rephrase the question as, how many atoms of carbon are there for every 356 grams of C6H12O6? Okay, now try figuring it out by pausing the video. Okay, so I've assumed you've kind of thought about it a little and tried doing it. Now let's do it ourselves. So let's figure out what they want. They want us to convert grams. Let me do it in a different color. Grams of glucose to atoms of carbon. So let's get started with that. So we start off with 356 grams of C6H12O6. over 1 times the amount of grams in that in C6H12O6, and we'll figure out that out at the end of the question, and then that's going to be divided with 1 mole, because that's for 1 mole, grams per mole, so it's going to be 1 mole of C6 and just dot. So we're going to times that by 1 mole of that element. I'm just going to write G, capital G, so you don't get confused with grams. And then that's going to be over 6, it's going to be over Avogadro's number, as we mentioned, whenever we convert to atoms. This time, we're converting it to molecules. So yet again, this Avogadro number works for molecules and atoms, as mentioned previously. Molecules of G. So you're going to times it by the amount of atoms in the glucose, which is 6 atoms, because it's C6H12O6, so there's 6 atoms of C. And finally, the 6 atoms for every 1 molecule. Because for every 1 molecule of this, or 1 mole, or this molecule for this matter, it's going to be 6 atoms. So molecule of G. Oh, it looks a bit like 6. Okay, now, as we mentioned earlier, we have question mark grams of C6H12O6. So let's measure the grams per mole of that molecule. Now, if you look at your periodic table, you realize that carbon has 12.01 grams per mole. So for every 1 mole of carbon, there's that many grams. For hydrogen you'll realize that for every 1 mole of hydrogen, there are 1.008 grams per mole. And for oxygen, it's 16, or precisely 15.999. 16 grams per mole. Now, let's figure out the quantity. So in C6H12O6, we have 6 of these carbon atoms, 12 of these hydrogen, and 6 of these oxygen. So we're going to times each number by 6 and then add them up. So let's do that. And just calculate it in your calculator. So we start off with 12.01 times 6. That's going to be 72.06. And then we're going to add it to 12 times 1.008. Which is going to be 84.156. And then we add it to 16 times 6. And you're going to get an answer along the lines of 180.156. So if you calculate all of that, add it all up, you'll get an answer of 180.156 grams per mole. So you replace question mark grams with this number right here. Now let's calculate our final answer. Our final answer is going to be, let's see, 356 grams. Oh yeah, and yet again, to confirm that we've cancelled out our units, grams of C6H12O6 are cancelled out with grams of C6H12O6. 1 mole of glucose is cancelled out with 1 mole of glucose. molecules of glucose are also cancel out with molecules of glucose. And we're left with atoms of carbon, which is what we wanted, because they asked how many atoms of carbon are there. Okay, so let's calculate now. 356 divided by 180.156. It's going to give us something like 1.97. And then we're going to times that by 6.022. And sorry, I missed something. It's actually 6.022 times 10 to the 23. Or to the 23rd power. So then you're going to get times 6.022. It's going to be around 12. Or I got 11.89. And then you're going to times that by 6. And you have your answer of 71 is approximately 0.4 atoms, or 10 to the power of 23 times 71.4 atoms of carbon. Or if you wanted it in a different notation with a one-digit number, then it's going to be 7.14 times 10 to the 23 atoms of carbon. So that's the answer for question number 2. Now, I'm gonna end us off with a reverse type of conversion. Or not reverse, but a one that we were supposed to do, but it's reverse now. Okay, so the question asks, it wants us to convert 3 times 10 to the 23 atoms of argon to grams of argon. Now, but previously, with these type of questions, we would convert grams to atoms. Now we're doing the reverse, so we're converting atoms to grams. Okay, so let's get started. Now we have to acknowledge that, remember that it was grams to moles to atoms. Now we're going to go from atoms to moles to grams. So let's get started. Okay, so we start off with our 3 times 10 to the 23. So 3 times 10 to the 23, or to the 23rd power, atoms AR, or argon rather, over 1, times Avogadro's number, or times something over Avogadro's number, which, as we mentioned previously, was 10 to the 23 atoms, 10 to the 23, times 6.22, and 6.022, and then, so Avogadro's number of atoms of argon for every 1 mole, because as we mentioned, for every 1 mole of our atom, there are Avogadro's numbers of that atom. And then, for every 1 mole of argon, we're going to have a certain amount of grams of argon. Now, to determine that, we have to look at our periodic table. We have to search for AR. So, if you go, it's actually in the noble gases, which is to the very right. It is right below neon with an atomic number of 18. And you realize that it has about 40 grams per mole. Precisely 39.948 grams per mole, but let's just say 40 grams per mole for our purposes. 40 grams per mole, or just 40 grams. Now in this case we're just going to say grams because it just wants the grams. So if we calculate this, bring our calculator right here, and before we do that, actually, before we calculate, I don't know why I always forget, we have to actually double check if we cancel out our units. So we could cancel, in this case, we could cancel out 10 to the 23 from 10 to the 23, and we could also cancel out atoms of argon. We could cancel out moles of argon, and we're going to be left with grams of argon, rather. Now, we can actually calculate this in our head. 3 times 1 over 6 is in fact 1 over 2. Then 1 over 2 times 40 grams of argon is equal to 20 grams of argon. And that's your answer. If you wanted to convert it to grams of argon, you'll be left with 20 grams of argon. So that has been it for the video. Hopefully you've enjoyed it. Hopefully you've learned probably learned how to convert grams to any other unit, and hopefully you've learned with this question how to do it reverse. Anyways, that has been it. Have a nice day. Bye!